In this demo, we will see various O-RAN SMO use cases with the help of the ONAP projects like SDNR, DCAE, etc. So the main focus is on the three parts here. The first one is the provisioning management, where we will connect the simulators to the SMO, and the other one is the configuration management. From the configuration, we will push the changes to the simulator or the device, and third one is the fault. Step details perspective, I have already deployed AMCOP, which acts as a O-RAN SMO, and there is a simulator, so which is based out of Netopia 2, which is having the required YANG models for the RU, CU or the DU. Let's start with the provisioning management, where we will connect it to the simulators. So there are total two things what we want to demo. First one is the manual way of connecting the device. I already have some of the simulators which are already connected to the SMO, and we will add a new one now. So this one is the manual way, where you will add the required details of the simulator. Currently, if you see, I gave all the details, and like the name, port, IP, port, and the netconf. Basically, the credentials whatever I have given is the SSH credentials. So if you see the highlighted part, it successfully established a connection to the simulator and its connected state. There is another way where we can establish a connection via TLS also. So we are going to see that right now. I already have a simulator which is configured to connect with the TLS. So for that, we just need to select the TLS, and the key, the prerequisite here is you need to already add the key to the SDNR. So I already added, that's why I can see the key here, whatever the key ID. So upon selecting it, we need to connect. Let's refresh it. Yeah, now it established the connection via TLS, and for subsequent any calls, the communication between the simulator and the SMO will happen via TLS. Now we will see the feature PNF plug and play. So now whenever the device comes up, brings up, and it will send a PNF registration event to the SMO, and SMO will pass that particular event, and it will try to establish the connection to the simulator. So basically, if you see on the right hand side, I have an event, and I try to establish, I send it to the west collector of the ONAP, and from the west collector, SDNR reads that information and it's established. In that event, the highlighted part contains all the credentials. With this information, SDNR able to establish a session. We will see the configuration management now. So let us take one of the simulator, and let's look into the configuration of that. So in the configuration page, it shows all the configuration based on the YANG. So let's look into the 3GPP common main element. The simulator is already having some of the initial configurations. So that configuration now we are going to see. So it has various levels of hierarchy. So we are digging deeper to see the details. If you see here, so under the mainiest element GNB CUCP function, we are seeing all the attributes. We can change the fields as we want, and we can save the changes, and after saving, and it will be pushed from the SMO to the simulator. Now we will see the fault management. And so fault management is basically, it shows all the faults which are generated by various devices. Currently the simulators which are already generating some of the faults, you are able to see that. That means under the hood, the SDNR is passing the details and adding it to the DB. The final information is visible here. In the alarm log, you can see more details of each and every alarm. The last column, if you see the source, so SDNR is able to parse both netconf and also the west notification what it receives. Yeah, that's pretty much about this demo. Thank you.